Good morning, students. Let's get started. Today we will have our lesson on exponential functions, and we will learn how to graph those functions. But before we do that, we'll start with our do now, where we'll complete a prompt about how stress can help us overcome challenges. Our objective will be to learn about graphing exponential functions, and our essential questions are: how can I graph exponential functions, and what is an asymptote? Our assignment will be to complete the do now, complete the 2 pages. There are some problems and some notes. There is an exit ticket, and if you're a distance learner, submit your work on Teams. If you are in person, I need to see your work. So we have for homework tonight, homework 7, 2 pages, because there are graphs. Important, I want you to please be committed, and I want you to focus if you wish to move on to geometry in high school. We're moving into some of the more difficult concepts in algebra, so you need to really practice every night with that homework. We will come back to our exit ticket, but for now, I want you to think about this question. Stress can help us grow because it encourages us to overcome challenges. How could entering a school-wide pie contest, which is what we have today, help you build stress resilience? And I truly believe that if you lean in, and I'm really big on leaning in, if you lean in and put yourself out there, that you can really grow and mature and learn to do even harder and harder things. But you've got to lean in to do it. So that's my thought on that. So let's get started. An exponential function is one in which the independent variable is defined by an exponent. So the independent variable defined by an exponent. They are functions, so they are in the form of y equals, and in this case, y equals a times b raised to the exponent, to the x power. So exponential functions are defined by the equation in the form of y equals ab raised to the x power. If b is greater than 1, the function is an exponential growth function. And the function is increasing. So we're talking about this b value right here, if b is greater than 1. If b is between 0 and 1, or if 0 is less than b and b is less than 1, then the function is an exponential decay function. And the function is decreasing. And the best way to wrap your head around this is to do a lot of graphing. So first we start with something called an asymptote, and you'll be talking a lot about asymptotes when you get to Algebra 2. So an asymptote is a line which the graph gets close to, but it never touches or crosses that line. So it never touches or crosses that line. And we're going to be using Desmos a lot today to help us out. So we have our first exponential function, one of 6 today, and the function is y equals 2x. So how are we going to graph this? Well, we'll start with a table of values. So we have x and y. So let's start with -2, -1, 0, 1, 2. Remember, these are functions. So when x is -2, we have y equals 2 to the negative 2. Then y equals 1/4, or we'll use decimals today, 0.25. When x is negative 1, then y equals 1/2, or 0.5. When y is 0, we know 2 to the 0 power equals 1. When y is 1, when x is 1, the function equals 2. When x is 2, the function equals 4. So all I've done is I've substituted these values for x and have evaluated the function. So then we plot these points. So we've got 2, 4, 1, 2, 0, 1, negative 1, 1/2, negative 2, 1/4, and we can try to connect these with a smooth line. And we can take a look at the graph and we can evaluate the graph, whether it's growth or decay. Obviously, this is a growth graph. And we can evaluate the domain, the range, the y-intercept, and the asymptote, the line that the graph gets close to but never touches and never crosses. So let's take a look at this on Desmos. And there's our graph, y equals 2x. So we can see that our domain is all real numbers. This graph will go to infinity in the positive and negative direction as far as the x values are concerned. But the y values are all those numbers that are greater than 0. This y, the asymptote is 0, is y equals 0. This graph will never cross the x-axis. The y-intercept, the place where the graph crosses the y-axis, is right here, 0, 1. So let's answer those questions. So the domain is all real numbers. The range are all those values that are greater than 0. The y-intercept is an ordered pair. 0 will be the x value because it's the y-intercept. The y value is 1. And the asymptote, that line that this graph will never cross, is y equals 0. So now we're going to graph y equals 1/4 x. So let's get a table of values. And for this one, I'll use the same values for x. These are, you think of these as our try-on values. So here, when x equals negative 2, 1/4 raised to the negative 2 power is 16. When y equals negative 1, when x equals negative 1, the value of the function is 4. 1/4 raised to the negative 1 power is 4. When y equals 0, the function equals 1. That's pretty simple. Anything raised to the 0 power equals 1. When x equals 0, the function equals 1. When x equals 1, the function equals 1/4, and I'm going to put that as a decimal today. And when x equals 2, the function equals 0.625. I need a 0 there, 0.0625. So now let's graph that. So 2 and 0.0625 is going to be real close to the x-axis. And then 1.25 a little further from the x-axis. 0, 1 is our y-intercept. Negative 1, 4, and negative 2, 16, which will be off the graph. So as we try to connect these, first thing we see immediately is that this is a decay function. because the function is decreasing. The domain is still, in this case, all real numbers, because if this graph goes to infinity and to negative infinity, the function will cover the entirety of the x-axis. And it's going to negative infinity because this is going out to the left as it goes up. So the range, like the first one, this function will never cross the y-axis, the x-axis, excuse me. The range is y is greater than 0. We will never cross the x-axis. The y-intercept is 0, 1. And our asymptote is the x-axis, which means y equals 0. So let's take a look at this one on Desmos as well. And there you have it, much better than the one we tried to draw ourselves. You can see the y-intercept of 0, 1. You can see that the graph will never cross the x-axis. So the x-axis is the asymptote for this graph. So let's move on to another one. We have y equals 3 to the x power minus 1. So remember, in an exponential function, the independent variable is an exponent. So let's make our table of values. And I'm going to go with the same -2, -1, 0, 1, 2. So when the exponent is -2, the value of the function is -0.8. When the exponent is -1, the value of the function is -0.6. And both of these are irrational numbers. So we have to put that line across the top. When the exponent is 0, then the function is 0. Because if we have a 0 here, this would be 1 minus 1. And 1 minus 1 is 0. When the exponent is 1, the value of the function is 2. 3 minus 1 is 2. When the exponent is 2, the value of the function is 8. 3 times 3 is 9, minus 1 is 8. So we can graph those values. We have -2, -0.8, right about there. -1, -0.6. We have our y-intercept is actually the origin, the 0, 0 point. And then we have 1, 2, and 2, 8. And we'll draw a smooth line. And we see still that this is a growth function. It's increasing. We see also that the domain is all real numbers. In the range, the x values that are covered, well, you can see that if this is -1, that this graph will never cross y equals -1. So I'm going to use another color to kind of show you that. So the graph will never cross y equals -1. So we can say that the range is y is greater than -1. Now, the y-intercept is the origin, 0, 0, and the asymptote is then that y equals -1, which I drew in orange. So let's take a look at this graph on Desmos, and there it is. And you can see the y-intercept is the origin, and you can see that this graph is never going to cross this line. Never, never, never. No, always remain above y equals -1. Okay, let's move on. Y equals 1/3 raised to the x power plus 4. So we start with a table of values. Same that I did before. I'm going to use -2, -1, 0, 1, 2. When I evaluate this function for -2, y equals 13. When I evaluate this function for -1, y equals, the function equals, or y equals, either way, 7. When I evaluate this function for 0, y equals 5, because 1 plus 4 is 5. When I evaluate this function for 1, the function is then an irrational, comes to a rational number, 4.3. And when I evaluate this function for 2, the function equals 4.1, again, irrational. So if we plot those points, -2, 13 would be way up here, -1, 7, 0, 5, there's our y-intercept, 1, 4.3, and 2, 4.1. Draw a line as smooth as we can. And we can get a good look at what the asymptote is on this function. So this function is never going to cross the line y equals 4. So that's our asymptote. So this is a decay function. The domain is all real numbers, because this will eventually go to infinity and -infinity, because as this graph goes up, it will also go outward toward the left, toward -infinity on the range, on the domain. On the range, this function will never go below y equals 4. So the range is all values that where y is greater than 4. And the y-intercept, as we see right here, is 0, 5. So let's take a look at this. And there's our function. There's our y-intercept, 0, 5. And you can see that this function will never cross y equals 4. So let's do a couple more. Now we have y equals 1/4 times 2 to the x power. So let's start with a table of functions, and I'm going to use the same x values that I used before, -2, -1, 0, 1, 2. And when I evaluate this function for -2, the function is worth, and we use decimals today, 0.625. When I evaluate this function for -1, the function is worth 0.125. When I evaluate this function for 0, the value of the function is 1/4. And since we're using decimals, we'll put 0.25. When I evaluate this function for 1, the function equals 0.25, or 1/4. Or I'm sorry, 0.5, because it's 1/4 times 2, which is 1/2. And when I evaluate this function for 2, the function is worth 1. So because it would be 1/4 times 4, which equals 1. So let's graph these values. We have 2, 1, 1.5, 0, 1/4, -1, 0.125. It's kind of hard to do it with this pen. -2.625. This will be better when we see it with Desmos. but roughly this function will go like this. It is a growth function. The domain is all real numbers. We're able to see that. We'll look at the graph on Desmos in a few minutes. The range, though, you can see that this function will never cross the x-axis. So the range will be y is greater than 0. So our asymptote is y equals 0. And our y-intercept right here, 0.25. Now, let's put a heads up 0 in front of the 0.25. It's hard to see the y-intercept right there. So let's go to Desmos. And now we can see it a little bit better. There's our y-intercept, 0.25. And we can see clearly, though, here that this graph is never going to cross the x-axis. So the x-axis, or y equals 0, is the asymptote for the function. Now our final one for today, y equals 5 times 1/2 raised to the x power minus 3. So we have our x and y values, -2, -1, 0, 1, 2. And when we evaluate this function for -2, the value of the function is 17. When we evaluate this function for -1, the value of the function is 7. When we evaluate this function for 0, the value of the function is 2. When we evaluate this function for 1, the value of the function is -0.5. And when we evaluate this function for 2, the value of the function is -1.75. So let's try to graph that. Here's our y-intercept, 0, 2. We have -1, 7, -2, 17, which would be way up there. It's off our graph. 1, -5, -0.5, 1/2, and 2, -1 3/4, right about there. So roughly, this is what our graph looks like. And this graph will never, ever cross the line y equals -2. Okay, so our asymptote is, I'm sorry, I believe that's -3. It's not clear. I probably could have evaluated for more numbers here. I just happen to know this because I graphed it on Desmos, so I'm going to graph this again because I just happen to know that if I continue to evaluate larger numbers, that this graph does have a y asymptote of y equals -3. So here's our asymptote right here. And again, you don't always use these same numbers. They're a good place to start. But if you're not getting enough information for your graph, then you're going to need to either put more numbers on the negative side of what you're evaluating or on the positive side. So the domain obviously is all real numbers. But the range is all the values of y that are greater than -3. So y is greater than -3. Our y-intercept is 0, 2. And our asymptote is y equals -3. So let's take a look at it on Desmos. And there it is. You can see it much better here than in our hand graph. But you can see clearly, well, first of all, that the y-intercept is 0, 2. But you can also see these values of as I move my stylus along this graph, you can see that this graph is headed toward y equals -3, but it's never going to get there. This is where it will always be. So again, this is a decay function. You see as it's getting less and less, it's decreasing. This is decay. So it's a lot to do today. You have some problems for homework that are similar. Let's go back to our exit ticket so we can kind of wrap up what we're doing here. So an exponential functions are defined, let's get a color that'll show up, by an equation in the form of y equals a times b raised to the x power. Now let's look at that b. If b is greater than 1, the function is exponential growth, and the function is increasing. If the b value is less than 1, or if it's between 0 and 1, okay, 0 is less than b is less than 1, the function is exponential decay, it's decreasing. Okay, so that function is decreasing. So take a close look at the b value when you see these functions. So tonight, I'd like you to try these 2 pages on the homework. Looks like 10 problems. Try them. You may use a calculator to help you do the evaluations, but keep at it because with practice, you'll be great.